Hi everyone, thanks for your time to attend the Wiwynn openEDGE session for OCP 2020 Global Summit, which was canceled due to the COVID-19. My name is Gregory Liu, and my topic today is Enrich openEDGE platform for 5G solutions. In this presentation, as we worked with WNC with strong new web for the switch sled concept, therefore, Chirko is invited to co-presenter here. Our agenda focuses on two parts. The first one is Wiwynn's approach for Edge, including the way we are moving forward, and I will give more details in the next slides. For the second one is Wiwynn's reaching out for solutions based on openEDGE design. While we are trying to utilize openEDGE platform in the coming 5G era, we are also thinking that the switch sled could be a potential demand in the near future, not only to enrich the openEDGE platform in function, but also provide more cost-effective way. Let's start with the first part. Here is Wiwynn's theme for 2020 OCP Global Summit, Open from Cloud to Edge. As most of you will know that Wiwynn grow with OCP Foundation at Cloud Offering, which is also the data center infrastructure technologies mentioned here. Since that demand at edge side increases in terms of latency, bandwidth, and hundreds of IoT devices are hooking onto the internet, we are moving toward the edge as a parent trend. So AI edge product for 5G field applications and the 5G RAN core products for COSPs are emerging as new stars. Under this circumstance, Wiwynn is preparing our edge offering, which is also building block based. As you can see from openEDGE high definition, high density series, we start with EP100, which is designed according to openEDGE spec, also is following the EIA 19 standard with 17 inches chassis in depth. And we are offering the 1U sled and the 2U sled, as well as the sled interposer for standard motherboard offering, like we are working with Ampere now. And last but not least, the switch sled. Furthermore, we are also devoting ourselves into edge server development for those small data centers who prefer generic COTS servers, the COTS servers like below offering. Chassis for 19 inches at width, while depth can be adjusted according to how powerful the end application asks. For example, single processor can offer you extremely short chassis solution, while dual processor can offer you short chassis but with much more PCIe options built in. With the help of modular design options, we can easily switch from different storage types, the E1.S, U.2 drives, and the large form factor hard drives, and even some expandable PCIe card solutions. Wiwynn Edge solution toward Edge AI shown here is separated into three categories. The first is Edge inferences. Second is 5G radio Edge cloud rack. Third is switch sled, which is also for codes. And we started with EP100, then offer the 1U sled for edge inferences, then 2U sled for broader edge application like radio edge cloud, then COTS sled to adopt different standard functional boards. In this case, we are working with Ampere for ARM processor, and of course the switch and or the bypass sled we will introduce later on. We will reach out to WNC to work out for end-to-end 5G solutions And as SA mode was just released late last year, our live demo is set to use 5G NSA sub-6G connection to show our hardware capabilities. Then we will show our plan for 5G SA standalone mode, which follows ORAN MAC standard. At last, we invite WNC to give detailed information regarding the switch select. We take the 5G FR1 NSA mode following with ORAN front hole interface split option 7.2 with TCP and MAC. Of course, we start with a EP100 system and trying to fully utilize this hardware. This is the end-to-end live demo topology from user equipment to EPC, then to application MAC. According to NSA mode, user equipment will first build up the connection via 4G LTE RU through NSA-capable LTE vRAN DU and CU with the help of NFV on generic servers. We build the DU and CU on top of one of the slate in EP100, then connect to EPC and ask video streaming services from MAC. After the EPC recognizes that the 5G connection is possible, then data plane will be transferred to 5G vRAN DU and CU via 5G RU so as to achieve 5G high bandwidth performances. Again, we are here to show our hardware capability and the readiness of virtualization on top of generic servers. Next is our 5G SA ORAN network plan. Let's start with the UE this time, and also the 5G radio unit are both provided by WNC. To realize the SA mode, we can still leverage EP100 here with below configuration. Please note that this configuration is just an example, and since that our solution is based on generic servers, you can always do dynamic resources allocations adjustment based on real application conditions. Here we start with slate 1 and 2 to support 5G vRAN, that is DU and CU. Then we take slate 3 to 4 to support 5G MAC servers applications, which focuses on providing compute, storage, SmartNIC. This is the option that we can offload certain loadings to improve overall performance. On top of virtualization layer, all the applications should be involved in, including near RT-RIC, the near real-time RAN intelligence controller. Last, we still keep a slate for 5G core network and SDN ORAN non-RT-RIC. This is the complete 5G network functions we are moving now. Next is the network slate provided by WNC. Basically, we have two design concepts shown below. First one is the networking slate interface among the internet and the sleds inside the openEDGE chassis. Next is a passive architecture to reduce the complexity of fiber connections.
Hi everyone, my name is Xueko, R&D lead from WNC's Wired Infrastructure BU. It's my honor to have this opportunity to talk to you about WNC's innovative OCP solution.
Leverage technology at our data center. Networking bandwidth grows quickly from 10 gig or 25 gig to 100 gig, 200 gig, and even 400 gig, which puts great pressure on the ability of a network to undergo an infrastructure upgrade. In the original openEDGE chassis, interconnections among the sleds pass through an external Ethernet switch. This means there is no need to redesign the chassis when bandwidth requirements change. However, extra space is required for an Ethernet switch or for more cable connections between sleds and the Internet. But if we want to reuse the existing cabinet, there is no room for an additional Ethernet switch. So the lack of a data connection standard in openEDGE causes three major issues. There is no easy installation standard for openEDGE server interconnections and external connections. The complexity of cabling causes high installation and manpower costs. The extra switch and the cables become a challenge due to space limitations. WNC proposes placing the networking sled inside the openEDGE chassis, which would solve this problem. The proposal comes with a switch sled and a passive sled as an end-to-end solution. The switch sled is a 10 QSFP28 port switch, and each port can be configured as 40 gig or 100 gig. Each port can be separated as a 4x10 gig or 4x25 gig port with a breakout cable. The passive sled is a passive optical breakout sled with two MPO type connectors and 8 LC type connectors. Let's take this image as an example. There are 4 openEDGE chassis at different locations. Only one chassis with a switch sled is connected to the aggregation or core switch at a central office. The other 3 chassis have passive sleds and are located at the factories near the office with easy wiring installation. The passive sled can be integrated through the first port of 4 server sleds with LC type cables and transferring through a MPO type port number 1. This also integrates the second port of the 4 server sleds to another MPO type port number 2. Hence, we can use only 2 MPO fiber connections in this networking pass-through sled connecting to the networking sled at the office building. The networking sled in the office building combines all the traffic and connects to the Internet. The concept of a networking pass-through sled yields lower costs when installing fiber between different buildings. In this example, 2 MPO type cables can replace 8 LC type cables, and it also makes things easier for technicians in setting up different types of cables.
In summary, WNC contributes a networking sled which provides the interconnections among the sleds in the chassis. It eases the space limitations and reduces the number of fiber connections. This concept benefits the customer in terms of setup costs and the flexibility to upgrade bandwidth in the future.
Wiwynn, your best choice for workload optimization and TCO.
Hello everyone. Welcome to visit our workshop right here. So if you have any questions, feel free to bring it up. Okay. Thanks, Min. Looks like there's no further question right here. Let's end this workshop. Thank you.